Okay, welcome everybody. My name is Andy Lieber. I am a co-director at, sorry, just admitting someone. I am co-director at Electrify Central Ohio, and I'll be presenting today our kilowatt hour. Madeline, if you want to say a quick hello, go for it.
Hey, Madeline, I co-direct Ego with Andy, but he's got the lead on this one because this is his wheelhouse of all
All
this stuff.
right.
Yes.
Well, it's great to have folks here. Today, our topic is energy resilience and backup power. For those of you who are not familiar with Electrify Central Ohio, we are a nonprofit organization that is based in Central Ohio, but we do like helping people out from all over. We're interested in focusing on consumer education, building community, and providing direct support. We do free coaching. Everything we do is free in our free time when we have it. And we just want to help people get fossil fuels out of their homes. There's a lot of people interested in doing that, but they're not always sure exactly what that path is to doing so. So we won't really be talking too much about that today, but that is our main focus. So if you're looking for someone to help make a plan, someone to be your coach and or a guide, we're the people. Okay, so today's topic, sorry if I'm going to talk quickly. I have so much information packed in today. I will hope to get through as much as possible, but if I don't cover things, just feel free to save it for the Q&A at the end. Um, so the question we should be starting with is why would you have energy backup? And the most obvious answer for many people is to keep your house running when the grid goes down. If you have a power failure, what do you do? Well, people seem to be increasingly concerned about this, and we did not plan this, but there was a power outage not very long ago, and a lot of people were out for a few days. But we've been seeing in the news that power outages are more and more frequent, possibly due to climate change, possibly due to strains on our infrastructure. There's a whole just confluence of reasons why that's the case. And this was highlighted by Bad Bunny's Super Bowl halftime show. There's especially difficult challenges in Puerto Rico. So it's kind of on our national consciousness. And you'll see these headlines like more outages are coming for a variety of reasons. And of course, when it comes to economics and money, then people really get concerned. Uh, it helps to put things in perspective. How much outage do we typically get? So this is data from the U.S. Energy Information Administration. On average, how much is the typical consumer um, or ratepayer in Central Ohio going without electricity? And it's typically between 4 and 10 hours per year. Some people individually kind of broke that record for the last 8 or so years, but to put things in perspective, we actually have a pretty reliable grid in Central Ohio. But nevertheless, people do want to have reliability and resilience when the grid goes down. So what are the things that we're interested in? Well, if you have critical medical equipment that you need to keep running, you want some power source for that. If you want to prevent flooding in your basement, if you don't want to lose your groceries, keep the heat running, and then things like internet, TV, basic lights, and pretty much everything. You can go as far as you want depending on what you're willing to invest. Another reason, which we won't talk about too much today, is load shifting. So what do I mean by load shifting? Well, I'll just quickly talk about this because I predict that if you haven't been thinking about it yet, you will be in the next few years. This is very important for some places in the US. I don't know when it will become meaningful to us, but if we look at the typical electric uses based on time of day, you can see that overnight it's rather low. And then we reach this big peak in the afternoon to early evening when everyone comes home from work, they start turning on things, cooking, and so on. And air conditioning is also at its peak. This is a typical summer pattern in the afternoon to early evening. So the problem is, if we look at this from the point of view of how the energy grid works, our grid, when you hear that our grid is being stressed, it's not always stressed. It's only sometimes stressed. So let's say we have our generation, which around here is mostly natural gas and nuclear and some coal, some renewables. So we produce the electricity at a variety of generators, and then it goes through these regional high voltage transmission lines and then it eventually gets distributed to us locally through these local distribution lines. Some of the pain points are how much energy can these lines carry? And they have their limitations, and it's really expensive to upgrade these sorts of wires. Um, so one thing that we know is that it really only becomes an issue when we push that peak usage higher and higher year after year. And people are probably thinking about data centers, which if they're connected to the grid are also consuming a lot of electricity. So one of the things that other states do, and you could do voluntarily if you wanted, is try to shift when you consume electricity from your home. So in 6 a.m., when there's not a lot of electricity being used, you could, 6 a.m., everything's great. 6 p.m., that's when everything is stressed. I made the power lines red. Um, but you could be charging a battery when there's not a lot of people using the grid. And then you could be discharging the battery and powering your home. And what you're doing is you're shaving how much usage is at that peak period of time. So what you would end up doing is if there were a lot of batteries, the grid utilization would look more like this sort of thing. And then that saves a lot of stress on the utility. So I promise I wouldn't talk too much about this, but people always ask about it. So there's a basic explanation. There's a lot more detail that goes into it. And Madeline knows way more about that than I do. But
Andy,
nevertheless,
is there peak period pricing?
no, not really. There is an optional plan, but it generally would cost you more if you enrolled in it.
Okay,
Um,
thank you.
Sure thing. So when we do load shifting, we're reducing consumption at peak hours to ease transmission and distribution bottlenecks. And we can talk about also the need for peaker plants and other sorts of things, but I won't get to that today. Just keep in mind that the message here is batteries could allow you to shift when you pull electricity from the grid, but AEP Ohio, if you live in Columbus area, does not yet have a meaningful program that would vary your pricing based on the time of day, or if you've ever heard of the phrase virtual power plant, where you could be contributing energy at certain times of day when it's needed. Most, there are small things like there's very small programs, but not too meaningful yet. Okay.
And I'll just throw into as like a slight ray of hope, maybe that's part of the reason why that's not available locally is because our regional electricity market isn't really set up to pay people for that, at least at like the residential level. There's like commercial industrial customers that can participate in the like wholesale electricity market. But PJM is our regional grid operator. They're changing their rules to let smaller fish like us participate at some point in the next like 5 to 10 years. That may lead to to flow down to the place where you or I could be compensated for shifting our electricity use based on time. But as Andy said, not right now.
And once we can do that, it really would be a win for sustainability and just for the cost of infrastructure. So here at Electrify Central Ohio, we're rooting for that to happen. Okay, so let's talk about our backup options. I'm going to talk about fossil fuel options and battery options, of which there are so many. So some people who are coming into this to learn might feel totally overwhelmed. I'm going to throw a lot of information at you. It's okay if it doesn't all stick, but we're going to record this. You can visit it later and talk to us, and we'll walk through things. So I apologize in advance if I fly too quickly through this. So before I talk about the options, I want to clear up some terminology first. And the first term that I want to talk about is a kilowatt. And a kilowatt, which you'll see denoted as the kW, is how much energy you are drawing at any given moment. And if we like put this in real terms, you can think about when you buy a microwave or a range stove oven or a heat pump or air conditioner, we can look at how much those things use at any given moment. So let's say they're all off and we're measuring your usage, then we turn one of them on. Microwaves generally consume about 1,000 watts, which is 1 kilowatt. And we can see that while it's on, we're consuming 1 kilowatt. Let's say we turn on something else, maybe a couple burners. Now we're up to 3 kilowatts. Then we turn on the heat pump, and now we're up to 6 kilowatts. Okay, that's the kilowatt. Now, that is not the same thing as a kilowatt hour. That's the sort of thing that you see on your utility bill. How many kilowatt hours did you consume over the course of a month? So that's the energy, but it's also times time. So for example, if you're consuming 6 kilowatts right this moment, then how many kilowatt hours does that translate to? It just depends on how long you're doing it for. So in this case, if you have all of that stuff on for 30 minutes or a half hour, then you've consumed just 3 kilowatt hours because you're multiplying half of an hour times 6 kilowatts. And if we were only had those things on for 10 minutes, then it's only 1 kilowatt hour. Similarly, if it's on for 2 hours, 6 kilowatts times 2 hours is 12 kilowatt hours. Why am I telling you about all this? Because kilowatt and kilowatt hours are both two important terms to think about when you're looking at any sort of backup power for your home. Okay, so how does it matter? Kilowatts determine how much you can use in any given moment. If you have low kilowatts, but a huge number of kilowatt hours of storage, then it's great that you got all that storage, but it's basically like, you know, putting out a fire through a straw. Kilowatt hours will determine how much total electricity you can consume. So if you're going to have a grid outage for a half hour, you probably don't care that much about how many kilowatt hours you can provide. But if you're going to be out for weeks, then the kilowatt hours become much more important. Here's some useful numbers to consider. The typical home rarely draws more than 20 kilowatts at any given moment. If you think about your electric panel, it might be rated for 100 or 200 amps. Amps is basically your kilowatts times your voltage, which is 240. So this translates to, I think, about 88 amps or something. Most homes rarely exceed that amount, but we have larger capacity for those moments where you happen to consume a lot more. The average Ohio home, in terms of kilowatt hours, uses an average of 28 kilowatt hours a day. Fully electrified homes, if you have a heat pump, you have an EV, you've got all these other things, you might use almost or even twice as much as that. Also depends on the size of your home, whether you're renting or have 5,000 square foot, mansion or whatever. But these are just averages. In an emergency, you can get by with much less. So if you just want to keep on your fridge, your Wi-Fi, and your essential lights, because Wi-Fi is so important, then you might be consuming 1 kilowatt of power. And over the course of the day, maybe less than 5 kilowatt hours of energy total. So it just depends on how frugal you want to be. Okay, so here are some additional considerations for the backup source that you will choose for your home. I'm going to talk about fossil fuels. So just generators, basically. These can essentially run forever as long as you have enough fuel. And that's a big if, but if you provide for the fuel, you can run those things just on and on and on. But this is not practical for load shifting, which really isn't relevant right now. But if you ever find yourself in that situation, you would never turn on a generator to help out the grid because they're inefficient and they're way more expensive per the amount of time that you're using them. Batteries, they don't generate any electricity. They just store it, and then they can shift it into your home. The prices of batteries have fallen dramatically. I attempted to put a figure in here, but they're still costly. And they've possibly inched up a little bit because of tariffs and also an important tax credit went away. But they're still they're sort of hitting their sweet spot in terms of their cost. With batteries, the storage can run out quickly if you don't have a way to recharge them, unless you want to spend a lot of money on batteries. And we'll get to that. Okay, so I'm going to begin with fossil fuel options. Why am I talking about fossil fuel? I'm with Electrify Central Ohio. We're all about getting rid of fossil fuels. Well, the first thing to consider is that the environmental impact of manufacturing fossil fuel generators is actually generally lower than batteries. It's hard to make a direct comparison because, again, one produces energy and the other just stores it. But for the uses that we would have in mind, it's possibly a lower carbon footprint to occasionally burn some gas than it would be to put this big battery in your house that required mining and all sorts of other things. So if you were using the battery a lot, then the math would change a little bit. But if you're using it 8 or 10 hours a year, then the gas that you burn in that amount of time really is kind of negligible. So I don't want to spend too much time on this, but there's analyses of what we call cradle to grave. So this would be from the moment that something is, every piece of it, the manufacturing process, the transportation, and all of that to get it into your home and get it set up, and then for its end of life to dispose of it. How much fossil fuel does that generate? And we can look at this in carbon, CO2 equivalent emissions. Um, and if you have a portable gas generator that can go for quite a long time, that might be less than a large portable battery. If you want to compare a whole house standby generator, which I'll talk about, that would be less than buying 2 Powerwall batteries. And again, the fuel use 8 to 10 hours a year is almost negligible. So let's talk about those fossil fuel generators. The first option is a portable generator. Many people have them. So before I got into all of this stuff, I bought a generator. We had young children in the house, and we just wanted to make sure we had an option in case of an outage. We have never used it. That just tells you how infrequent our outages have been. We bought it almost 10 years ago. So, but here's how they work. They generally provide between 1 to 12 kilowatts of power. So that any given moment, that's how much you can be drawing from your generator. You can use them to power critical devices, but larger generators can power most of your home, like a 12 kilowatt generator. As long as you're not turning everything on at once, you can pretty much handle just about everything. The fuel sources, you can have multiple options here. Some of them are dual fuel or tri-fuel, where they have inputs for gasoline, propane, and natural gas. For the most part, people would be using gasoline or propane. And the thing is, with gasoline, the fuel will last about 90 days before it starts to degrade, unless you add fuel stabilizer, which you can go buy at any hardware store or auto store. Then it will last for 2 years. So you can buy a bunch of gas cans, keep them in the garage with some fuel stabilizer in them. Or if you're really on top of things, you can just rotate them. You just always pour those into your car and then fill up the empties if you just keep track of it. They can use as little as 0.2 of a gallon per hour for only your essential needs. But if you want to have that big portable generator running all the time, it can use more than 25 gallons of gas every day to cover most or all of your home. Propane, if you get a bunch of those tanks, the blue Rhino tanks that everyone sees everywhere, well, propane lasts basically forever. It does not degrade. But if you want to have like 15 tanks lying around, that's going to cost you quite a bit of money. They can use as little as 0.1 of a gallon per hour for your essential needs, and they can also use more than 24 gallons a day to power your whole home. So 24 gallons, that's more than one of those canisters. So you just have to think about how much would I be going through, depending on what the needs are for my home. Natural gas, if you want to power these, you can just get a hookup somewhere near the side of your house. You roll your generator over to it, you hook it up, and then you can basically run your generator for as long as the natural gas supply is running. Okay, so more about this. What are some considerations? You have to do annual maintenance just like you would on a gas lawnmower. Oil change. There's a starter battery in many of these, so you want to make sure that doesn't die on you. Usually you can override that, but it's good to keep that maintained. It must be placed outside. It's been estimated that 85 people die per year for not using them properly. So they keep them in their attached garage, and then they die of carbon monoxide poisoning, which is colorless and odorless. So you got to be really careful about that. You can't keep them out in the rain. So if there's a huge thunderstorm and you have an outage, well, you're probably going to wait till the storm's over before you turn on your generator. They're loud, of course, and they're dirty. And they're highly inefficient. So about 15 to 20% of the fuel that you burn actually turns into electrons that power your home. And part of that's due to idling. A lot of times you're not using much electricity, but the generator is still on. It just has to run. It's not ideal to run these overnight for long periods of time without monitoring them. So a lot of the issue with the generator, people think, well, if I could just run it a few hours at a time, no problem. But I don't like the idea that it's out there running all day. And we're going to return to that issue. So our recommendation is to buy what's called an inverter generator. The power that generators produce, let me put this another way. The way that we use power for our electronics in our house is they expect a very specific kind of thing that we call a sine wave, and generators might not produce a nice, pretty sine wave, and it can actually damage your electronics. But if you buy an inverter generator, it will produce that clean sine wave for you, and you'll be able to power your electronics with it. And they're very popular on the market now. What are the costs of these? The equipment could range from that $450 for the 2 kilowatt generator all the way up to around $3,200 or more for the larger ones. Okay, 2 hookup options. So if you got that generator, how do you use it to power your home? The main thing that people tend to do is they just run extension cords. They put the generator out in their yard, and then they run extension cords to the critical appliances like your fridge, your lights, your Wi-Fi, and so on. But you cannot use a generator to run a hardwired appliance. So let's say you have a gas furnace. That will have some electronics in it. You have a blower motor that needs to be powered that blows the air around your house. And there's a logic board that talks to your thermostat and all that stuff. So you have some electricity that you would need, and that's all hardwired. Unless you have an electrician come in and insert a port that you could plug into a generator, which you could do for a few $100s, you're not going to be able to heat your home. Similar with heat pumps and all those other hardwired appliances. But this generally gets people through the basics, and it only costs the price of extension cords to hook it up that way. The next one is the manual transfer switch, or an interlock. So this right here is an extra thing that goes next to your main electrical panel. And you just move some circuits into here, the ones that you care the most about, your fridge, maybe a basement fridge or freezer, or other sorts of things. Now, obviously, these are only options if you own your home. If you're a renter, I don't think your landlord would be happy about doing these modifications, but you can move these things over into this transfer switch, and then the generator powers the transfer switch. This is another option called an interlock kit. You put this little thing here that means that what you have to do is you have to turn off the power from the grid. That's your main breaker. And then you can slide this thing over, and then you can turn on the breaker that allows you to power from your generator. It just prevents backfeeding electricity into the line during an outage so you don't harm or kill a lines worker. And that's required by law. So you would flip that switch, and then you can support anything from your whole panel or just a handful of circuits that way. The next piece is you need to plug in your generator. So that's an inlet box right here. This goes on the side of your house. It's connected to one of these 2 things right here. And then, as you can see, this guy is plugging in his generator, and that's powering his home. So how much does that cost? For any combination of these 2 things, it's generally going to be, plus the electrical work, will cost anywhere from $750 to $2,000 to set up. So the generator plus that. So if we put this all together, if you just want a small generator and extension cords, $500, you're good to go, plus the cost of fuel. Mid-size generator with that manual transfer switch, maybe you're spending $3,000. Large generator interlock, you could be spending $4,000 and up. Okay, we're moving. Standby generator. This is a step up for the fossil fuel approach. Here, they generally start around 10 kilowatts. So this is at the higher end of a portable generator. And they go all the way up to 26 kilowatts and sometimes beyond. If you've ever seen commercial buildings, they have much larger generators. But the available products for residents look like these. This would be for homeowners. Again, if you're renting, this would not be an option for you. You can do partial home backup with 10 kilowatts all the way up to whole home backup, where you don't even have to think about anything and everything's just working just fine. A lot of people with standby generators don't even know that there's a power outage. So it's integrated into your home electric system, even more so than that the plug-in thing that I just showed you before, because it has something called an automatic transfer switch. When it detects that the grid has an outage, within 1/50th of a second, it switches you over to your standby generator. These can be hooked up to either natural gas, which is most common in a place like Central Ohio where people have a Columbia gas account, or you can hook it up to propane. If your house is all electric, you might not have a natural gas account anymore. If you're planning on going all electric and you want to save on fixed monthly charges, you might be planning to get rid of your natural gas account. So getting a standby generator that keeps you on natural gas might not be a good option for you. If you want to use propane, you need a large tank. Generally, people might have at least 250 gallons, but usually 500 gallons, which can cost somewhere between $1,200 to $5,000 to install. The $5,000 would be if you have a 500-gallon tank that you're burying underground. You can also rent tanks, but then that is a little tricky because you're paying a contract when you're hardly ever using the propane. It's only for emergencies, so that wouldn't be a very good deal. These need a professional installation, and annual maintenance is required. So usually the company will come out, check on it, send you a little bill, and then they'll tell you if you're good to go. These are best for long outages and maximum comfort. If you don't want to think about anything and you've got money to blow, you can get a standby generator. One thing I should note, there are some people who are really hardcore into worrying about, we can call them stuff hits the fan scenarios, where there's just like societal chaos around. And if the grid is down for, let's say, if that happens, there's a lot of other bigger problems than having power in your house. But if the grid is down for like 1 week to 1 week plus, the thing is that the natural gas grid does rely on electricity, and they have their own backup for emergencies, but in some cases it might not last forever. So it's possible that in some cases the natural gas supply could fail. And then even though you're hooked up with a standby generator, you have no electricity in your house. That's a real sort of sky is falling situation. But if you want a standby generator, typically the installed cost of this whole package is $8,000 to $16,000. The most popular size is 22 kilowatts. It's considered whole home backup, as long as you don't have literally everything on at the same time. And the average cost there is about $12,000. All right, those are your fossil fuel options. Now let's talk about batteries. So what comes to mind when you think of a home battery? And when people think of home batteries, I'm going to answer that for you. They think of the Tesla Powerwall. It is probably the most widely adopted home battery solution, at least for an integrated solution. And I'm going to explain what I mean by that. So it's integrated with a solar array. A lot of people who are looking for one of these batteries already have rooftop solar or are planning on buying it at the same time. If you've gotten a quote for rooftop solar, they've generally said, here's a quote for a battery if you're thinking about one. And it works together with your solar. So during an outage, the solar array can keep charging up your battery. So in theory, as long as the sun is shining and it's not covered, the panels aren't covered in snow, you'll be able to have at least some electricity every day. And the house can function in this off-grid situation indefinitely. However, there are some important considerations for doing something like this. So your house is connected to the utility, and what we don't want to do is to be powering our home and sending electricity back to the utility when there's an outage. Because again, there could be a lines worker on there and we could electrocute that person because they're not anticipating any energy coming from your home. And it's illegal to do that in an outage. So by law, any what we call a grid-tied solar array, it must be shut down or islanded, meaning that you have to sever the connection between your house electrical system and the grid. So that has to be islanded during an outage to prevent any risk to line workers. What is islanding? Well, in order to do it, you have to get special equipment that isolates your house from the utility during that outage. And it's expensive to have the technology that allows you to island your home. So we call these batteries grid interactive batteries. They're like the Powerwall. That's one example of many, and they can charge again from solar during an outage. Now, the thing is that most people think that when you have solar on your roof, you can continue to use solar when there's an outage. That is only the case if you have a battery like this. One of the issues is if you don't have a battery, the solar electricity will just go up and down and up and down, and we don't want to damage our equipment. So we need to know that there's a constant supply of electricity. So it's usually with a battery that you can keep using your power. All right, so what about the grid interactive battery? It is the most integrated solution you can find. So again, you can island your grid-tied solar array during that outage, and it allows you to continue to producing electricity with those solar panels. If you don't have solar panels, There might be some reasons why you would get a battery like this, but it's generally only if you live in a state that has load shifting. Otherwise, it's way too complicated and not worth your effort. It's most expensive of all the battery options because of the complex technology you need to do that islanding. But it is seamless operation. It's just like having a standby generator. The power goes out, your battery immediately starts supplying your home, and you might not even know that there's an outage. Batteries, depending on how much capacity you have, can run either part or all of your house. And again, with solar, you can run it indefinitely. It depends on your array size and the weather. So, you know, on the one hand, maybe you don't have a huge solar array, maybe it's cloudy, but at least you're getting some electricity every day. In a long-term outage situation, gasoline, propane, those things could be scarce. And then there's actually an advantage to having a situation like this. Battery chemistries are evolving. If you're looking for batteries, any of these batteries, this apply to anything I say about batteries, look for, this is lithium iron phosphate. That's LFP chemistry, or LiFePO4 is what you'll see. It is safer, and it's also cobalt free. Cobalt is known to have serious humanitarian issues related to mining. And people still think that most batteries have cobalt, but they do not anymore. At least a lot of them don't. Other things that I won't get to today that you should check out is if you're going to buy a battery like this, look at how long it's warranted for, what's the quality of that warranty, what is the efficiency of that battery. So you have to convert with solar, you convert electricity from DC to AC and sometimes back and forth, which means you lose some efficiency. I can talk about that in the Q&A. And then what's the maximum system size that you want? Here's just a comparison of 3 leading battery manufacturers for basically their standard sizing. So how much storage are you actually getting with that one battery setup? These are pretty comparable. The Franklin is more, and then Tesla, and then the Enphase. This is the 10C. Enphase also makes a 5 kilowatt hour battery. And then how much power can you get? A lot of times you'll see peak power versus continuous. If an appliance comes on, it surges initially, and your battery can handle that. But for continuous loads, this is kind of what we care about. It's about half as much as those standby generators I was telling you about, but this number can double or even more if you get more batteries. This is just the baseline. And these are pricey to install. So they're already in the same range as a standby generator, although they've got much less electricity because again, it's about half of that 22 kilowatt capacity plus the energy in a standby generator is limitless. You can run it constantly for weeks on end as long as the supply of natural gas is there. But you can run out of this energy in a day or a half a day, depending on how much you're taxing, the battery capacity. And then the pricing. When we look at all batteries, we're going to compare rough estimates of how much money do you spend per kilowatt hour of storage. So the Tesla is actually a pretty good deal. That's why a lot of people buy it, to say nothing about your opinions of that company. And then there are things that people like about these other batteries, but you do pay more. So it can get pricey, to say the least. As I was saying, these numbers can go a lot higher if you get more than one battery. All right, that's our good interactive battery. Now I want to just go to the other end of the spectrum, which is our portable battery. I'm already looking at the time. I'm going to try to talk for about 8 to 10 more minutes. I guess we started a few minutes late, so I'm going to do my best. Portable batteries are all over the place. They're small. They're typically only 1/4 to 3 kilowatt hours of energy storage. Not very much at all. They're just used to power your essentials. Charge phone, your laptop, even run the fridge for a little while. If you have a 3 or 4 hour power outage, these can handle the job. You can also take them on the road. If you like to go camping or tailgating, these are great to bring along if you want electricity on those outings. They have multiple outlets and USB ports on their side, so there's a lot of different ways you can charge from them. Popular brands that you'll see, these are the top 5: EcoFlow, Anchor, Jackery, Bluetti, and Yeti. And there's more than that. So if you have such low capacity, a lot of times you'll see that they're advertised alongside these portable solar panels. They're lightweight. You just toss them somewhere in the sun, and they don't produce a lot of electricity, but if it's sunny, you can be getting up to 2/10 of a kilowatt, and then an hour of that would fully charge a battery like this almost. But if you just keep it in the sun all day long, it can add up. They cost about $175 for these. Okay, our recommendation again is look for that LFP battery chemistry. And the thing I didn't mention about that again is also the standard lithium ion batteries are much more prone to fires. These are much safer. Another reason, if you're going to keep something like this in your house, get that LFP battery. Typical costs for these are about $400 to $600 per kilowatt hour. So much less expensive than those than the grid interactive batteries I was just talking about, because there's not complex technology to hook it up to your home. All right, now we're going to go up one step from those portable batteries to batteries that are very similar. They're just larger capacity and they usually have more things that they can do. And we call these home power station batteries. So two examples are the Anker Solix F3800, and it can come with expansion batteries, and also the EcoFlow Delta Pro Ultra. These are technically portable. I have this one. It weighs 130 pounds. It's on wheels. You can move it, but keep that in mind. 130 pounds is not something you just pick up and toss in the truck. The base units for this class is about 3 to 5 kilowatt hours, but you can expand them with these expansion batteries, depending on the system, for anywhere between up to 20 to 90 kilowatt hours. So huge amount of storage. Also a lot of money. Many models offered by these brands is the same brands that you saw with those portable units. So Jackery, Bluetti, they also have similar products to the two that I'm showing you right here. They can be recharged with more than just that portable solar panel. So you can use portable or even off-grid solar panels. If you're handy and you want to hook up some solar panels, you can do that as long as they're not connected to the grid like the rooftop installations that you may have paid an installer to do. And I'll talk about that a little bit more. You can use a portable generator, and you might be thinking, why would I do that? It's actually a really good option that I'll explain. So what you can do, let's say it's a storm, and you can't drag out the generator into the yard because it's pouring out there, and it needs to be covered from the rain. So maybe you don't want to go outside or even think about that in the middle of the night. You just hook up one of these, you're good to go for 6 to 24 hours. And then at some point, as the battery begins to decline and it's how much it's stored that's left, then you can recharge it with a generator. And then you only have to run that generator for a short period of time. So a generator could recharge this in 1 to 2 hours. And then once it's recharged, you run off the battery again. You get much more efficiency out of a portable generator because it's not idling, it's running at full capacity, and then you turn it off. So that cuts down on noise, wasting idle fuel, and idling from fuel and so on, idling with fuel and so on. Okay, you can also, I like to joke about this, but it's a real solution for some people. If you live next door to someone with a standby generator, you're not going to ask them for an extension cord to power your home, but if you're close with them, you might say, hey, do you mind if I recharge my battery? And they might let you do that. So for most people, it's a joke, but you can also recharge a battery with your EV, and I'll talk more about that in a little while and why you might want to do that. Okay, so how do you use these home power stations? Well, they can actually be optionally integrated with your home panel, just like the portable generator that I was showing you. Same equipment, you get that transfer switch with the inlet, and then you can get the same plug that goes into your home, or you can even get an advanced power panel device like this, which can work more automatically. This, you have to manually turn it on or off, but it powers those hardwired things in your home. But this one is more like the standby generator, where it just charges and discharges the battery based on when you might need it. And it can also do load shifting, again, not super relevant for us right here. So here's an example, the Anker Solix F3800. It has about 4 kilowatt hours of energy stored. You can add up to 6 expansion batteries, and you can even link 2 of these units and have 12 total expansion batteries and get 54 kilowatt hours of total storage, which is quite a bit. Sample costs for this sort of thing. Let's say we want to make it comparable to those integrated battery solutions. Well, we would get, let's say, the F3800 plus 1 expansion battery. In this case, we'd get 3 expansion batteries for this setup. That would cost you to $6,000 to $6,500, about half as much as those grid-tied batteries that I was telling you about before, like the Powerwall. So only about $430 per kilowatt hour. But, and if you install the home power panel, then it adds about $2,000 to the cost, and then you're looking at spending $8,000 to $8,500. That's about $535 per kilowatt hour for that sample system. All right, I won't spend much time on this because if you know how to do DIY stuff, you're not here. I mean, maybe you are, but there's a whole ecosystem of DIY products. It is by far the least expensive option because you have the know-how to build these systems yourself. There's a huge online community, as I mentioned. They're highly customizable. They're often combined with people who have off-grid solar arrays, maybe a ground mount in their backyard. You need to proceed with caution on these. If you don't know what you're doing, please don't do this. You could hurt yourself or burn your house down. And a lot of times you need to see if your homeowner's insurance policy will allow you to have systems like this in your basement. And you would need to get it permitted. But for something like the size of the Powerwall, with all of this stuff, it runs your home, and it might only cost about $6,700, which is $435 per kilowatt hour. This is Will Prouse. He has all these YouTube videos. He's incredible. I've watched quite a few, and I was tempted to go this route, but I decided not to. All right, I'm almost there. What about your car? You may have heard this buzzword bidirectional charging. Well, if you have a huge battery already sitting in your garage or driveway, wouldn't it be great to use that? They have anywhere between 65 to 125 kilowatt hours, or some vehicles have 200 kilowatt hours. I think the Hummer has 200. So you could power your home for a week or something, and then when you start to run low on your battery, just drive it somewhere, charge it up where there's electricity, and then come home and then power your house for another week or so. This is called, one option is called the vehicle to home, where you're sending energy directly into your electric panel. This is very complex. It requires expensive equipment. Most of these systems are proprietary. So if you have a Ford F-150, you would buy the Ford F-150 bidirectional vehicle to home charging kit. And then you get rid of that car, and all the money you just spent is wasted. There are some what we call vehicle agnostic devices, which can be used with any vehicle, except a lot of vehicles don't have the technology to use those, and the technology is changing, so these things could be obsolete in a few years. They cost anywhere between $5,000 and $15,000 to install. It gets pretty pricey. It's not as simple as just plugging your car into your home and you're good to go. So it's an option, but just think carefully before going this route. We say it might be a risky investment now, but this could change in the next few years. All right, I'm flying through this. I'm getting really close to finishing up. The other option that I really love is called vehicle to load, where you put this thing into your charging port, and then you flip this open and look at that. I can plug something into it. So this is where you can plug a standard appliance or any electrical cord into your adapter. It provides 1.5 kilowatts of power. It's like a portable battery, but it has huge capacity. It has the 65 to 125 kilowatt hours. It only works with some car models, which is such a bummer. My Chevy Bolt cannot do that. You buy the adapter, and then you're good to go. There are limitations of bidirectional charging. The big one is if your car's not there, you can't power your home. All right, so let's put this all together. I just flew through so much stuff. Hopefully your head is not completely spinning, but we are recording this and we'll post it and we'll be available to answer questions. But what do you do? Well, all right, you have to figure out, what do I want? Do I want full integration versus manual options? If I want full integration, I'm probably looking at a standby generator or a grid interactive battery. How much energy do I want? If I want the bare minimum, I could probably get by with a portable generator or a portable battery, maybe with portable panels. If I want all of it, then a standby gas generator again, home power station, grid interactive battery, vehicle to home, those sorts of things. Do you have a solar array that you want to use during an outage? Well, then you need a grid interactive battery. It's the only option for you. What about if you don't have a natural gas account or don't plan to have one? Then a portable generator, propane standby, or batteries, not a natural gas standby generator. You want to minimize your carbon footprint? Well, surprisingly, you might be looking into a fossil fuel option, that portable gas generator, and see if you can use your existing car battery because that doesn't add any carbon footprint to the manufacturing process. It's already in your driveway. If you're planning ahead for load shifting, I was talking to someone recently who said, well, even though we don't get paid for load shifting, maybe you just want to be virtuous and help the grid out by consuming less energy during peak hours, and you can use a battery for that purpose. You are a saint if you do that, but then you would need batteries to do so. Okay, one last thing. This is a lot, but I'm going to go through it quickly. This is the setup that we have in our house that we basically never use because we never have outages. We didn't even have an outage in the storm that we just had last week. So 2016, we bought a generator before I knew any of this stuff at all. And batteries were extremely expensive back then. So like I said, we never used it. But to this day, I still have gas in my garage with fuel stabilizer in it. But I don't want to be running a generator all day long. So about a year ago, we bought the Anker Solix F3800. It was cheaper then because we got a 30% federal tax credit, but this is what it costs now, $2,100. If you wait for Black Friday deals, those are a good time to buy, or other big sales. And then when I was planning ahead with some upgrades that we did to our home, we added this sub panel that has all the critical circuits that we would want to power. And then we just added this interlock setup. It only cost us $500 to add that only. That's still a lot of money. And then just because I'm a nerd about solar, I went to a solar installer and asked them if they had any spare panels they would sell me cheap. And I found someone who took me up on that offer. So for this and the cables, I spent $300 and I got 800 watts of solar just sitting in my garage. We have all the solar on the roof, but that won't work during an outage. So I can drag these out in the driveway and then hook them up to power this thing. And then we have a fireplace that came with the house, and we just keep some wood around. So what happens? When the power goes out, we start with the battery. If the battery starts to get depleted, then we have a few options. We can try to hook up the solar to keep charging it. If we need to, we hook up the generator to keep charging it. And also, if it's cold out, we can use the fireplace to keep our house warm. So I'm all about multiple different options. The thing is, if we run the generator, we're not doing it continuously. We only have to do it long enough to recharge the battery. And that is so much more pleasant. When the power goes out in the middle of the night, we just turn on the battery. I don't have to drag anything out of the garage, especially if it's a thunderstorm. So all of this together today would cost about $3,650. And I just described all these things here. So yes, there are future options to do load shifting. We can add that device that integrates it with where it's automatically controlled, where it's using the battery, depleting the battery, and so on. So this is much less expensive than a grid interactive battery or a standby generator, and we can almost achieve some of the same things, but we cannot use our rooftop solar output during an outage. That's a main consideration. To do that, again, we're spending at least $12,000. Okay, I'm not even going to talk about this right now. I'm just going to leave it here and we can share the slides for anyone who's interested. This is just a way to look at all of the things that I talked about for a few different variables, and some additional advice. If you want to do some disaster preparedness, it's not just about having electricity on in your home. Go to ready.gov, keep some water, food, first aid kit, flashlights, and a hand crank radio available. It's a good investment if you need it in an emergency. Indoor, there are some portable propane heaters. There's a little complexity to that you can ask me about. And if you need to leave your house, the main thing is just, if it's freezing outside, shut off your water main and open your faucets. All right, 7:53. That was a lot. Sorry I talked so fast. We have time for Q&A, and I'll stay past 8 o'clock. So I could probably stop the recording now, and then we'll just take Q&A. Let's see here. All right.